Good morning, class. Today we will be studying about rectifier. Now, what is a rectifier? Rectifier means it is a device which converts AC signal into DC. So we can get pulsating DC, and also if we apply filter, then we can get pure DC. So let's now know more about this rectifier. So now as I said, it converts AC signal to DC, AC to DC signal. Now how does it convert? We need some semiconductors as like diode and then thyristors. So we can use these elements for our rectification purpose. So now coming to the rectification process, this can be controlled like of three ways. One is uncontrolled rectifier circuit, half controlled rectifier circuit, and fully controlled rectifier circuit. Now what is uncontrolled rectifier circuit? When I say uncontrolled rectifier circuit. Now what does it mean uncontrolled? Uncontrolled means we cannot control the triggering process or the starting on and off process. It is not in our hand to control that, as because we use a diode over here. We use a diode. Now for a diode, there is no triggering angle that is supposed to be in a SCR. In an SCR, we can trigger, we can give a trigger, or it takes some time to start the SCR. Diode starts right from the beginning point, and SCR starts after a certain point of time. That is called the triggering time. This one is the triggering time. So you can say if this is an output structure, then this can be the triggering time, T on time. But here we don't get any time to trigger. It rises immediately. It gives the output immediately. So that is why it is called uncontrolled rectifier. So now I am going to elaborate this in this circuit. We are going to study first of all about a half wave rectifier circuit. So this is a diagram of half wave rectifier circuit. Now what happens in this half wave rectifier circuit? When I say half wave, that means what? It is conducting only in one half of the AC cycle and the other half is turned off, or we can say in words of biasing, only one half is forward biased and the other half is reverse biased. So what is biasing? I have discussed in the previous class. In case of diode, when anode, if this terminal is anode and this terminal is cathode, then if I give a positive pulse here in the anode and the negative pulse in the cathode side, then it is said to be, it is in forward biased. Now vice versa. Now if anode and this is cathode. Now if we give negative here and positive here, then what happens? Then it won't work. So it is like a reversed biased. So now this is in a reversed bias. So this is to be implemented over this circuit. I will elaborate you about this circuit now. We have given an input that is 230 volt and of having 50 hertz frequency. I am using a transformer that can induce this input towards this circuit. Now when it comes to this circuit, If it is in the positive half cycle, now I am starting from this. You can see a input wave cycle. Now in this input wave, now this is an AC input. Here this is 0, pi, 2 pi, 3 pi. Full wave completes from 0 to 2 pi. It's a full wave. Now when I want to convert this AC into pulsating DC, what I need to do? I need a diode over here. Then I need a load. I have taken here resistive load. I am taking a load here. Then it's a transformer. It is generally a step down transformer I have taken here. Step down transformer. Now in case of when I am saying step down transformer, here the number of windings are less than the number of windings in the input side. Now what happens when it induced? This terminal is cathode and this is anode. This is A, this is C. Anode and cathode. Now when it is given a positive signal and this certainly becomes negative. Now this diode comes into play and it is now in forward biased. Forward bias means this one is conducting. So current can pass through this. We are getting a loop. So this is in the forward direction. So we can see in the waveform, I have taken voltage over here in the x-axis and in the y-axis we have taken time. Same here, if I am giving a waveform of output half wave rectifier, then how does it come? It is also for voltage I am saying now. So as it is a diode, it starts from here itself. It starts from here. Now it goes up to this. This is for when D is on. This is D is on. This diode is on, or it is now in forward biased. Now we can see from here, this is forward biased. Up to how much? Up to pi. Again, when this input signal is in the reverse direction, reversed bias, that means what? Now this anode side would become negative and the cathode would become positive. Now this is in what? This is in reverse direction. This is in reverse bias now. Reverse bias. So when it is in reverse bias, see the anode is connected to the negative terminal. So it won't conduct. So at this point of time our waveform will be like this. D is off or reverse bias. Again it's a repetitive work. So anode positive, cathode negative. Why? Because again from this point of time, this 2 pi, it again gets forward biased. So in case of forward bias, it would again give an output, same output. This is D on. Again for the reverse direction, off. So we are getting what? Pulsating DC. What we are getting? We are getting a pulsating DC. This is not a pure form of DC. We will give filter circuits to get pure DC. I'll go through that in the last session. Now what happens? You can note it down. D on when anode positive, cathode negative. Anode positive, cathode negative. D off means anode negative, cathode positive. Note it down. Okay. This is all about our half wave rectifier. Now when I say a full wave rectifier means we can also use this reverse bias thing. So what we need to do, we need to do some changes in this circuit. Again we will give an input of 230 volt 50 hertz a step down transformer with some changes in this circuit. I can take like, I'm changing this circuit right now. Center tap. We are going to use two diodes. Over here one and the another one is here. D1 and D2. We can put a load over here. This is for full wave rectifier. Center tapped. Center tapped full wave rectifier you can write, or you can write full wave rectifier with center tap. Here also we are taking a resistive load, that is R. Two diodes we are taking, one is D1 and another one is D2. So now when from the input side we are going to induce this to the secondary side. Now what happens? At this point this terminal becomes positive, this point becomes neutral, and this point becomes negative. So what happens? How this will conduct? If this becomes positive, simultaneously we can say here it is negative, here it is negative, and at that point of time this point is positive and this point is negative. Now which diode is getting forward biased? Whichever it will be forward biased, that particular diode will be conducting the circuit, conducting the current through this circuit. If this is positive, this anode and this one is cathode of this diode D1. When this positive is connected to the anode of this circuit, of this diode, then it is now forward biased. So the current can conduct through this, it can come over here through this load coming in this direction of the load, and it is completing a closed loop. So we can go through the waveform. For a full wave, I am getting an output waveform over here with respect to time. What I am doing, when D1 is on, again it starts from initial. D1, here D1 is on and D2 is off. Why it is off? Because if we go over here, it won't conduct, because negative is connected to the anode terminal. This one is the anode and this is cathode. If I say, it won't conduct. Now at this point of time this is reversed biased, so it is going to get through this closed loop, through this load R. So we are getting a waveform of D1 on and D2 is off right over here. From 0 to how much? 0 to pi. 0 to pi. Now when input is reversed bias, this one input was in forward bias. Now when input is in this form, now what happens? Now this particular terminal will become negative. This terminal will become negative. When this is negative, then what happens? This terminal becomes positive. Then it will become plus and this is minus, negative. Now what is the difference? Difference is, now this particular diode D1 will be in reverse bias because negative terminal is connected to the anode of this circuit. So this is reverse bias, and positive terminal over here in D2, it becomes forward biased as positive terminal is connected to the anode of this D2. So current again, it can flow in this direction. So the direction of this output is same. So we are getting an output in this direction only. Sorry. Okay. Now here D2 is on and D1 is off. This total process goes on repetition. So we are getting a pulsating DC when we are using D1, D2 as two diodes. In this, there are some of the disadvantages you can say, like RMS value goes on like increasing, root, that is root mean square value, RMS value increases. Then peak inverse voltage also comes into play. It is creating a problem in this circuit. For all these problems, we are going for a bridge rectifier circuit. You can note down for this full wave rectifier center tab D1 on when D1 on, D2 off. When is this? From 0 to pi. 0 to pi. D2 on, D1 off. Pi to 2 pi. Likewise it goes on. You can note it down. Okay. Now we are going to draw a circuit of full wave bridge rectifier circuit. Full wave bridge rectifier circuit. What happens in this full wave bridge rectifier circuit? We are using 4 number of diodes here. Cherry tab 4. Again we are taking a 230 volt input with having a 50 Hz of frequency. Right. D1, D2, D3, again it's a step down transformer. I'm drawing over here output waveform with respect to time. This is voltage. Full wave bridge rectifier with output. Okay, now what happens? When in the first half cycle, this part, input 0 to pi, what happens? In the 0 to pi, this terminal is now positive terminal. So, whichever diode gets forward biased, it will start to conduct. Now what happens? This current moves through this. Will this one will be conducting? No. This is going to conduct. So now the current passes through this D2. It will go through this load. Then it will move like this. Through D3 it is coming to here. Now it is completing a total loop. Now what happens? The current is flowing through D2, load, D3, then to this terminal. So we are getting output. It again starts from the initial point 0. Which are the diodes which are in conducting mode or in the forward bias mode? D2, D3. So we can write over here D2, D3 on and D1, D4 off. D1, D4 off from 0 to pi. For the negative half cycle, now this terminal becomes negative. So current cannot flow through this path, it will find another path to conduct. Which is the path we can find? When this is negative and this is positive, current will flow through, current will flow through this. It will come through D1, D4, then towards the load. Load is in the same direction again, D1, and then to this terminal. From positive terminal towards D4, then load, then D1 and to the negative terminal. So we are getting here output in the same direction, as because the load is having the same direction. In the first part also we are going through this direction, and in the second or the reverse direction we are also getting that same direction through this load. So here D1, D4 are in conducting. D1 and D4 on simultaneously. D2, D3 off. This is from pi to 2 pi. It continues as on. So we can note down some. For full bridge rectifier, what happens in the first half cycle? In the first half cycle, what happens? D2, D3 conducts. D1, D4 is off. Is on, you can write here. In second half cycle, D1, D4 conducts or is on, you can write. D2, D3 is off. So this is all about uncontrolled rectifier circuit with half wave, full wave center tapped, full wave bridge rectifier. So 3 things we have covered today. And here what we have given, we have not given a filter circuit. It is about the pulsating DC output, whatever we are getting. To get pure DC, we need to connect an inductor or a capacitor in the circuit. When we connect capacitor, we always connect it in the parallel. We always connect parallel to the output or to the load. And if we connect inductor, we connect it in the series to the output. For example, I am giving a small example. Let's take half wave rectifier circuit to 30 volt input with 50 Hz of supply. Okay. Okay, now we are giving it this. This is load. This is diode. Now what happens? If I am applying a filter circuit to it, simply you can connect here a capacitor. Now what is the use of a capacitor? Capacitor blocks AC and it allows DC to flow. So here it blocks the AC and this AC is parallel to, blocks, yes. It blocks the DC and allows the AC to bypass. So now whatever this capacitor is having, it is blocking what? DC. So this DC component is now induced to the load. So we are getting pure DC. So the diagram actually now waveform will change. I'll discuss all this in the filter circuit. We can use inductor. When we are using inductor, you can connect it through like in the parallel, in the series to the load. So this is all about rectifier. Next we will study about rectifier circuit, but it is fully controlled rectifier circuit. What we need to do in the fully controlled rectifier circuit? We can simply replace the diode with an SCR. Simple, it is very simple, because in SCR we are getting triggering pulse, that alpha triggering angle we are getting, that we can control as per to our need. Alpha triggering angle we have studied, that we can control according to our need, and we can implement those in our need of output. So thank you for this class, and please note down all these things. Thank you so much.